Hello everyone, so in this video we are going to solve a question of LeetCode. That is my calendar one. So let's start with a problem statement. You are implementing a program to use as your calendar. You can add a new event if adding that event will not cause a double booking. So what is this double booking? Let's see. A double booking happens when two events have same non-empty intersection. So what does this non-empty intersection means? This means that when we have already assigned a range to some book, right, when we have already assigned a value to some book, then that range should not be assigned to any other book, right? Or we can say the another new range must not lie in the previous range, right? So let's quickly see the first example. So in the first example we have these three books, so let's just copy it from here and let's take it here. Yeah, so we basically given three ranges, right? So in the first range we have 10 and 20. So let's draw this on a number line. Initially we don't have any book, so we just take 10 and 20, right? So we can take this because we don't have anything, so we don't have anything to compare with, so we can return true from here. Right, now let's see the second one. In the second we have 15 and 25. Right, for this 15 and 25, if we see the range, so we have 15 here and we have 25 here. Right, so for this 15 to 20, this is intersecting, guys, this is intersecting, so we cannot take this. So let's return false from here. Right, this is making a double booking, so we cannot take this. Let's return false from here. Now let's see the third one. For the third one we have 20 and 30. So for this 20 and 30, if we draw, this is 20 and this is 30 here, right? So this is not intersecting, right? Because 10 to 20, 20 is ending here, then another one is starting from 20 to 30. So both are valid. So in this case we are returning true, right? So I hope this is fine. Now let's see how can we approach this question. So the very basic and the brute force approach to solve this question is, let's say we compare the values, right? So how can we compare the values? So we have basically given a parameter, that is start must be less than equal to x and less than end. So let's see the same condition here. Let's say this is the first starting and first ending, so let's consider this as s1 and se1, and the second one is s2 and e2. This is the first, second starting and second ending, right? Now if we compare the values, right, so what is the valid condition for this parameter? So this should be this ending one, right? This ending one must be less than equal to s2. Let's write the same condition here. This e1 must be less than equal to s2, right? And the second condition would be, let's say this is the greater one and we get a lesser value here, right? So in that condition this must be on the left side, right? So for that left side, what would be the condition? E1, right? This e2 must be less than equal to s1, right? So let's write it here. This e2 must be less than equal to s1, right? If both the conditions are true, right, if both the conditions are true, then we need to return true from here. Else, what are the opposite conditions for this? So the opposite conditions for this is when e1 is greater than s2, right? This is the opposite condition, when e1 is greater than s2 and e2 is also greater than s1, right? So if both the conditions are true, then we need to return false here, right? So only this thing we need to do. Let's quickly code it up. So this is the brute force approach, and the time complexity for this, let's first code this, then we will discuss the time complexity for this approach. So for this, let's first take a vector to store the values in the each iteration. So this is vector, that is a 2D vector, and let's name it v. Now let's add the value. So v dot push back start and end, right? So before adding the value, let's also check whether this one is possible or not. So for this, let's run a for loop for auto x v, and let's see the code two conditions here. So what are these two conditions? Let's say for this x we get two values, x0 and x1, right? Because we are adding two values here. So what are this x0 and x1? Let's say this is x0, right, and this is x of 1, right? So what we need to compare is this x of 0, that is s1, right, that is x of 0 must be less than e2. What is this e2? E2 is basically and given to us. This is and, right? So this should be and, right? And this x1, that is x of 1 must be greater than s of 2, that is start, right? So if these conditions are true, then we need to return false here, right? We need to return false because we are writing these statements here, right? We are just writing these statements here. Let's write the same condition here. If x of 0, right, if x of 0 is less than end, right, if it is less than end, and x of 1 is greater than start, right, the same condition we have written in x of 1 is greater than start. So in this case we need to return false from here, right? And at the end, if we have added the conditions or the pair here and this for loop is successfully run for all the values, then we will be returning true from here because it's possible to add a value in this vector, right? So let's quickly run this. Yeah, it's working fine. So the time complexity for this approach would be this for loop will take big O of n because we are just checking for all the n pairs, and let's say we have to run this for n books. So the total time complexity for this approach would be big O of n square, right? This is the time complexity, and the space complexity would be big O of n because we will be storing at max n pairs here, right? So this is the time and space complexity for this approach, right? Now let's see how can we optimize this approach, right? So to optimize this approach, let's say rather than optimizing, let's first see another approach, which is the kind of approach which we can use in some variation of this problem. Let's say we have this problem, we have currently we are solving this my calendar 1, then we have also given the similar problems here, calendar 2 and calendar 3. So let's see the approach which is applicable for all the three questions, right? Then we will be moving to the most optimized solution that we can do through binary search. So before that, let's see one more approach which we can do it here. So let's first see that approach. So let me just take it here. Yeah, so yeah, so let's say we have given 10, 20, 15 and 25. So if we represent this on the number line, so this is 10 and this is 20. So whenever we get a starting point, we just represent it with +1, or we can say we can add +1, and whenever we get an ending point, we just subtract it by -1, right? Similarly, when we get for 15, we get 15 here, so we will add +1, and for this 25 we will just subtract it from here, right? So for this each we just calculate the sum. So if we calculate the sum for this, so we will get till here, we will get 1 plus 1 is equal to 2, right? And we already know this is not valid, right? This is not valid because this is intersecting here, or we can say double booking here, right? So we don't need to take this. So what we can conclude from here is that whenever we get a value which is greater than 1, right, like we have got 2 here, so whenever we get a value greater than 1, we need to return false, right? So in this question we have given double booking, right? Similarly in the my calendar 3 my calendar 2 we have given triple booking, right? And this is a triple booking, right? So for this triple booking what we need to do is we can take a value. So for that we can take this. So in the calendar 2 problem we just need to update this greater than 1 to greater than 2, right? Because 2 is valid in that, so we need to check for 3. But let's see for the current question which we are solving right now, that is calendar 1. So for this calendar 1 we have double booking, so for this we only need to check for greater than 1, right? You can solve that second and third questions after this question, and this would be more clear to you. So for this we have got the condition that is greater than 1, right? Now let's quickly see for the other cases, right? Now we have 20 and 30, right? So for this 20 and 30 we won't be taking this, and yeah, for this 20 and 30 we will get 20 as it is and 30 here, right? So for this we again get plus 1 and minus 1, right? So this is plus 1, then minus 1 0, then plus 1 minus 1 is equal to 0. So this is going fine, so we can return true for this, false for this, and true for this. Now let's quickly code it up. So let's reset this, and for this let's make a map of integer and integer m. Now let's add the values. So m of start plus plus and m of and minus minus, right? We have just decremented the values here. Now let's run a for loop to check whether this is going greater than 1 or not, right? So for this let's take a variable int sum which will be initially 0, and let's take auto it is equal to m dot begin, then it should not be equal to m dot end, and it plus plus, right? Now let's check if sum is, now before that let's just directly add sum plus equal to it second, right? Now let's check if sum is greater than 1. In this case what we need to do is we need to return false, right? We need to return false, this is fine, but we also need to remove this pair somehow, right? So to remove this pair what we can do is we can decrement the value. So m start minus minus and m and plus plus, we are just doing the opposite of what we have done here, right? If everything is fine then we need to return true here, right? So this should work fine. Let's try to run this. Yeah, it's working fine. So this is a second approach, and for this approach also we are taking the time of big O of n square, because for this we are checking for n pairs, so this is fine. And for this for loop again we are just traversing through all the pairs, or we can say all the values of the map, so this is also n. So the total time complexity would be big O of n square again, right? And this is big O of n, that is a space complexity, right? So this is fine, I guess, time and space complexity. Now you must be observing that in this case we are unnecessarily traversing through this, right? So what the other method we can do here is, we can, rather than doing this, we can do one more thing. Rather than traversing through the whole array to find this, we can, like in this case this map is sorted, right? This map is sorted. So to search an element in the sorted form, why to just traverse through whole array? We can use a algorithm. We already know we can use a binary search for this, because in a sorted array of n values we can easily use a binary search to find a value. So why not to use this? So this will just reduce our time complexity of this for loop, that is big O of n, to bigger of log of n, right? So that approach will reduce this time complexity to bigger of n log of n, because that for loop is unnecessarily taking bigger of n, right? So we can reduce that bigger of n loop to log of n in the binary search form, right? So let's quickly see how can we approach through binary search, right? So in the binary search, what we will do, we will first make a set for this, right? Why we are making set? So set is basically a data structure which is sorted, as well as it stores the unique value, right? These are the two specialty of set, right? So let's do the same thing here. Let's first make a set here. So set of pair int and int, right? This is fine, and we need to update this completely. So let's first remove the whole code from here, right? Now let's see how can we approach this question. So let's say we first store, well, let's say we first check 10 and 20 in the set, right? We don't find 10 and 20 in the set, so we don't need to do anything here, right? We will just add this into our set. But this is a very important step. We cannot directly push this into the stack, or we can say insert this into the stack, sorry, in the set, because in the set, when we compare the values through binary search, we just need to check this value, ending value with the starting value, right? But when we use a binary search initially, or the set will be initially sorting the values based on the first values, right? On the first value. But we need to compare these values, right? We need to compare 20 and 15. So in that case, while we will be using a binary search, so we just need to store the reverse order of this, right? We need to just store the reverse order of this. So we will be storing 20 and 10 in the set, right? I hope this is clear to you, because as we have already seen, we are just checking these values, right? We are just checking e2 is less than equal to s1, right? So they are checking the ending and the starting value in the each condition, right? So for this, initially, or we can say the predefined function will always check the first and first values, right? So to easily do it through the predefined functions, we will be storing this into reverse form, so that we can easily access the first values, right? This 20 will come on the first, and we can easily compare 20 with 15, right? So I hope this statement is clear to you, why we are reversing the values here, right? So let's do the same thing here. So before that, let's just find it here. So auto it is equal to upper bound, and let's find this. So let's find start and end here, right? This is start and end. Let's find this in the set. If this is found in the set, that is s dot upper bound, if this is found in the set, then it's fine. So for this, let's check if it does not equal to s dot end, it means we have some element, and let's check that element. So it second must be less than end. If this is correct, then we need to return false from here, else let's add the value. So s dot insert, let's insert the reverse order. So end comma start, at the end just return true from here, because we have successfully added the value in the set. It means we can book that event, right? So let's quickly try this on the sample test cases. Yeah, it's working fine. Let's submit this. Yeah, it's working fine. So the time complexity of this solution is bigger of n log of n, because n, we can consider this as a n pairs which we are traversing again and again, and log of n is for searching through this binary search, right? So the time complexity would be n log of n, and its space complexity is bigger of n because it makes we're storing n pairs into this set, right? So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.